All right. This is so exciting. I'm so excited. You've got the microphone. I want to welcome everyone to the very first inaugural student showcase. So what we've got is a whole bunch of school students from year 7 to year 12 who want to come and talk about an awesome project that they've all independently been working on. Some of these students have been working on this as part of a school project. Some of them have been doing it in their own time. We put the call out a few months ago to say, hey, what awesome things have you been doing? And we got in some fantastically amazing, awesome responses. We have selected a handful of those to share their stories with you. They're going to be rapid fire, so 10 minutes to talk. We will be accepting one question. If you have questions that you want to ask, you can tweet them at me or send them to the DM, on the Slack thing. I think that's probably the best way to curate them. Otherwise, if you've got a burning question and you desperately need to ask, put your hand up, and if you're lucky, I will call upon you. Otherwise, all of the students will be around after, except for one that needs to run away for a plane. So you can ask them there. All right. We are going to start off with Isabella Hogan. Isabella is from Sydney and is in year 7, and is going to talk about machine learning with noughts and crosses.
Hi, as Nikki just said, I'm Isabella, or I prefer Izzy. Before I start, if you have a pen and paper, draw up a noughts and crosses board and play with the person next to you. While you do that, think about this. How do you choose what move to do next? Do you use a random choice? Do you use strategy? Well, this is something I had to think about for my project. My project is a machine learning noughts and crosses game that works using a reward system. The way it chooses where to move is a random choice from a list of all the possible moves. But that's where the reward system kicks in. By adding or subtracting moves, I can force the computer to learn strategy by weighting the randomness based on whether the computer won, lost, or drew in previous games. I just said that my project is a machine learning noughts and crosses game. But what is machine learning? Well, machine learning is, as Wikipedia says, the subset of artificial intelligence that, in the field of computer science, that uses statistical techniques, blah, blah, blah. That's a very long definition. Here's my simplified version. Machine learning is the use of programming to make a computer be able to learn using data. The way I learnt about machine learning was my inspiration for this project. It was a YouTube video produced by Matt Parker of the Stand Up Maths channel about how some people at Manchester University demonstrated what machining is and how it works using some matchboxes. They called their version Menace, Machine Educal, yes, that's really a word, noughts and crosses engine, after the 1960 program by artificial intelligence pioneer Donald Mickey. The Manchester Uni Matchbox machine uses coloured beads, one colour for each square, in the noughts and crosses board to represent the moves. When the game resulted in a loss, all the beads are removed from the system. When the game, all the beads used were removed from the system. When the game resulted in a draw, the beads are replaced with the exact same bead as well. When the machine won, they replaced it with 3 of the exact same type to reward the system. Right. The name of this video shows, the name of this video is called Menace, a pile of matchboxes that can learn. After watching this video, I asked myself, could I do the same thing but with Python programming? And well, here I am. Okay, so I know I'm not the first person to try to make this project, as evidenced by the movie War Games, which uses similar machine learning. By the way, that movie has the wackiest way to connect to the internet I've ever seen. But I still had all my own problems to solve. The hardest one I had to solve was an endless loop that I couldn't find. I had to talk to my mum, Amanda Hogan, about it at first, and we thought it was a problem with the random choice. I worked around random with a random seed to help me work out the problem, but that really didn't help. After about 500 print statements and looking at the output line by line, I figured out that it wasn't a problem with the random choice after all. Instead, it was an indexing error. Because the computer was looking to put its move in the wrong spot, there was a chance that that move was taken already, then it would loop forever looking for somewhere to play. Because it didn't happen all the time, it was really hard to find. Off by one errors are the worst. As you can see on the slide, on board 1, the computer tries to move into spot 2, and it can't because there is a naught there already. Well, because it tries the one next to it. But then it tries another one, a random one, say 8. But it looks at the one before it again, and there's a naught there as well. So it keeps looping through, trying to do that over and over, but it can't find anything. This is the same as board 2. But I said that there was a reward system. So on board 3, let's just say that 1 and 2 were ruled out because they weren't winning. So it tries to move into 3 and 5 and 9, same as board 2, still doesn't work. I obviously had some other problems, but this was the most frustrating and most memorable because it was the most difficult to find. Okay, so at this point, I'm just going to check that you've all finished your noughts and crosses game and possibly met the person next to you. If you have, give me a thumbs up. Great. On with the talk. Before I show my live demo, I'm just going to warn you that I will be asking for audience input, so please, 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 so I don't look like a crazy person, please answer. Can I have a name? Anybody? Nikki. Okay. Where would you like to go?
0.
Another one? Oh, sorry, I took out all the print statements.
I see. 8.
There you go. So, still going?
7. 6.
You won. Yes. I'm just going to go back. My most proud moment in this project was making the flipping function that found all the possible transformation of the board to look for them in the dictionary. Indeed, I was so proud that I went to school the next day and I immediately showed it to my friends. This was basically the review I got. It's so weird, it keeps flipping every time I want to move. That was because to make the machine learning more efficient, I got rid of any duplicates that were flipped or reversed to find the board in the dictionary of all the possible moves ever. After having my eagerness deflate a little, I had to make a new function to flip it back. And here's how the flipping function basically works. To reverse it, you would just flip position 0 and 2, or 1 and 3, 4 and 6, and 7 and 9. And to turn it clockwise, you would flip 2 and 4, 7 and 3, and 8 and 9. Essentially flipping this one, yeah. And that's the different possibilities of one board. Okay, so I know that nothing is perfect, so here are a few things I want to change or add to my project. Number one, my user interface. Right now, my user interface is just some print statements, so I'd love to make this better by using Pygame or Kiwi, so it really is an actual game. And number two, my spaghetti code. My code is quite messy, and I would really like to sit down when I have some time and just make it cleaner and put in some comments, maybe. What is the best way to track learning? Well, for us students, it's assessment after assessment after assessment. I don't really know how to make an assessment for a computer, so I went to researching. After a bit of searching, I found this thing called CSV Writer. The first instance of this was somebody who wanted to reference the Monty Python video spam, and so there was a lot of printing of the word spam into an Excel sheet. I just replaced the word spam and everything else with my data stuff like where it moved to and stuff like that. My data. So after 400 games, yes, it was against a random bot, but who's really going to play that many games in a row? I found that my program was actually winning more than drawing or losing. As you can see, this one is my data, and it goes in a pretty steady upwards motion as it goes in the center place. But in Menace's data, as you can see, it has the different colors over here. It goes down a lot before it has to go up again. I was quite happy with mine. So, as the Looney Tunes say, that's all, folks.
That was fantastic. Thank you very much, Izzy. Sophie, can we get you on deck? Stay there, Izzy. Sorry. Yes, Joseph. Yes. Reading. I'm still too. I can't believe I won that noughts and crosses game. That was really. My heart's still racing. Questions. Do we have a question? Oh, okay. We have a question. Tony, ask your question, and then I will repeat it so that it's recorded as well.
I'll make it loud. Izzy, I'm your grandfather. How come you're smarter than I am?
Because I actually do some school things.
Oh, some nice sass coming back there from Izzy. Thank you very much. All right. Excellent. Joseph.
Thank you.
You're all good. Hang on. So Joseph Tay is from Melbourne, and Joseph is in year 11.
Yep.
Thanks.
All right. Hi, everyone. So I'm Joseph Tay, as she said. I'm currently a year 11 student in Haileybury College. Today, I'll be discussing my research on optimizing memory retention using a machine learning-based flashcard system built in Python. Obviously, that sounds a little bit convoluted, so I'll try and simplify things. So imagine you have a test tomorrow, and right now you only have 15 minutes to memorize 30 foreign words. What do you do? A common approach is to use flashcards, computer-based applications that help you to memorize information by using algorithms to selectively choose and present information at the optimal time for you to practice. However, most of these applications that exist are based on very simple rules and equations. Over the course of last year, I've researched various data-driven techniques to try and improve upon such traditional systems and more accurately predict when you are at the optimal time to study. But I guess you may be wondering, when is the optimal time to study? To answer this, here's a quick intro to how memory works. If you learn something new, you will slowly forget it. Note that chance of recall is essentially the probability of you being able to remember something at any given time. You must repeatedly revisit or review information to prevent it from being forgotten. In 1913, Ebbinghaus discovered that you learn better if there is a spacing between each time you review information. Now, this spacing can't be too long, otherwise you'll forget the information, nor can it be too short, otherwise the benefits are reduced. And thus, the best time for you to review information is on the verge of forgetting. This is the ultimate goal of the flashcard application, to predict when you are at this point in time. But how do we do this? To do so, we have to actually be able to predict a student's chance of recall at any given time. So according to the research of Ebbinghaus, we can calculate the percent chance of recall with this specific equation, an equation that mathematically describes how forgetting occurs in an exponential fashion. To calculate the chance of remembering something, you need two components. One is the time passed since last review, and two is a measure of memory strength, which is essentially how strongly an item is embedded in one's memory at any given time. So changing the memory strength value affects the rate at which forgetting occurs. And thus, my goal was to try and use machine learning to try and predict the memory strength value and in turn predict the chance of recall. We calculate this value using a heuristic approximation similar to what researchers Settles and Meter also used. Now, memory strength is essentially a culmination of your past study history. For example, the more times you have reviewed and studied the word, the more optimal the spacing between each review has been, or the more correct answers in total, the higher your memory strength value will likely be. But how do we use these features to try and determine a quantitative memory strength value? And so this can be posed as a classic machine learning problem. We take large data sets with over 100,000 student interactions from the PSLC data shop, which is a popular data repository for educational data, and use a machine learning algorithm to learn the patterns and relationships between features of a student's past performance and the student's current memory strength. The algorithm then produces a model that can predict a student's memory strength given such features. So what features specifically did we use to predict the student's memory strength? Settles and Meter's 2016 study used the number of correct and incorrect answers and the total number of reviews as features to predict the memory strength value. Reddy's study of 2016 also used a value that increased and decreased depending on whether that user answered correctly or incorrectly. It was derived from the popular Lightner system. And these models performed pretty well, but I tried to find new features that would raise predictive accuracy even further. And so I trained a simple regression model that with a range of different features to predict memory strength. And after much experimentation, I found that these three features performed most effectively. And a very interesting thing that I found was that capturing and prioritizing correct answers that were more recent significantly improved predictive accuracy. In fact, using only features 1 and 2, which were also used by Settles and Meter, yielded an accuracy of around 70%. However, using all three features led to a significant 8 to 9% accuracy boost, indicating that capturing how recently a student has answered correctly is a clear contribution and improvement to the models of past studies. This could be because more recent success may indicate that learning has taken place and thus leads to more accurate predictions. The model also performed comparably and better than a simple logistic regression model and a neural network that tried to directly predict the percent chance of recall. It also performed comparably with an item response theory model, which is a commonly used standard baseline in the student modeling community. And thus, this reaffirms the theoretical assumptions that the model is based on. So after the model was developed, I implemented it as an online web-based flashcard application built in Flask. This is its appearance. After logging in, students see this foreign word, type the English translation below, and click Submit. While this looks very simple, every time the user clicks Submit, the application runs the machine learning model in the backend to calculate the chance of recall for every single word. The application then selects and presents the word that is closest to being forgotten, which is the optimal time for the student to study it. I won't go into the technical details of the application for the sake of time, but it was essentially a basic Flask implementation with simple authentication. Now, as you saw previously, the model achieved a pretty high accuracy on existing data sets, but does this translate to an improvement in human learning? And more importantly, how does it compare with an existing simple application that doesn't use machine learning? This is what we tried to test by conducting a classroom experiment on around 40 Japanese language students. I tested my machine learning model against two other models, the Lightner model, which is a very popular and commonly used heuristic model used by many existing flashcard applications, as well as a simple control that presented words in a sequential order. The experiment targeted a very realistic and short-term scenario, and it lasted for 2 days. On day 1, students spent 15 minutes memorizing 30 English-Japanese word pairs, and on day 2, there was a test on all 30 words. So here are my results. On day 2, which is the test day, students who used the machine learning model scored around 40% on average, followed by the Lightner algorithm with 34% and the control with 28%. In fact, students who were assigned to the machine learning model forgot less words on average between day 1 and day 2 and had a higher overall accuracy during the learning phase on day 1. And so compared to a commonly used rule-based Lightner model, these findings show that a flashcard application based on machine learning is able to more consistently present information at the optimal time and consequently leading to increased memory retention. So how did Python impact this project? Now, initially, I used R language to develop the model with RStudio, but over time, I began to realize its shortcomings and moved over to Python. So why? Firstly, let me pose a situation. After training a model in R language, how would you deploy the model and use it to make real-time predictions in an actual flashcard application? The issue is that you can't write a flashcard application in R language. The language isn't designed to perform such tasks. You have to write the application in another language, and hence the only option is to deploy the model onto a web server and make predictions from there, which was too tedious and time-consuming for this project. On the other hand, Python makes it much easier to deploy a trained machine learning model because Python can be used to both train the model and develop the flashcard application. And so after training the model, I could use Python's pickle function to serialize the model and store it as a .pkl file. It can then be unpickled and immediately used in the flashcard application to make real-time predictions. Secondly, using Python has also allowed me to use a package known as Lentil, which is a package for training, evaluating, and visualizing models that specifically predict student knowledge. The library contains a base class or a parent class called skill model that you can inherit from and use to develop your own models to predict student knowledge. And by using this base class, you're given access to a whole set of other features, including a range of functions for model evaluation, including a range of relevant metrics. You can visualize data sets and student interactions. You can compare your model with other models in the literature that have been pre-coded in the library, and many other specific features in developing predictive models of memory. Now, while Lentil provides the framework for developing and evaluating student models, the actual machine learning algorithms and optimization processes are included in the scikit-learn library. I'm sure most of you have heard of this library, but it makes training regression models, neural networks, and other models a much more straightforward and simpler process. I also used NumPy and Pandas for data manipulation and processing, such as utilizing data frames, etc. And so, yeah, that's essentially a very brief overview of my research. The results of my investigation prompts commercial flashcard applications based on very simple rules and heuristics to take steps in adopting more advanced techniques. And an interesting thing was that during the course of my research, I noticed that a few apps, including Quizlet, are beginning to explore data-driven techniques and approaches in enhancing student learning. Clearly, machine learning is beginning to drive our technological improvements in education. And while my research focuses specifically on optimizing a flashcard application, such techniques can undoubtedly be applied beyond vocabulary learning and work towards a more personalized classroom environment in the future. So obviously I was unable to fully describe the extent of my research given the strict time constraints, but if you're interested in this and would like to read more about it, you can download the report in the link above, or ask me any questions via email or after today. And yeah, that's it. Thanks so much for your time and this opportunity. I hope you learned something. Thank you.
Thank you so much, Joseph. Language learning is going to be so much easier for me in the future. Hang on, you hold that because I'm going to find you a question while Sophie comes up. Do we have a question for Joseph? No, yes, okay. Katrina, you're going to ask the question. I'm going to repeat it for the video.
That means I'm going to ask a question that makes sense. This is going to be good.
Yes, no.
So you've put all of this effort in. Is this something then you could see yourself taking to the next step in the future to actually have up and running for other students and educators to access and use?
So, so Katrina was asking, given the fantastic amount of effort put into this, are you going to take this further? It definitely makes more sense this way. To be something that educators can use.
Definitely. As in, obviously, there's a lot of room for improvement with the application itself. I think one of the main drawbacks is and one of the main areas that I can improve upon is collecting more data and trying to individually adapt to individual students. Because obviously, the thing with this model was that it trained on a population of data. And one thing that I could do to improve it is to try and consistently retrain the model for each specific learner, and that way we could adapt to different learning abilities. So obviously I'm going to try and extend the application as much as possible, and before I actually release it, or right now it is online, it's under a domain name, but I have no plans of actually releasing it for educators because there's a bunch of other applications out there right now. But yeah, I'll try and improve it, collect more data, and yeah, hopefully one day.
One more super quick question from the Peanut Gallery online, because you're the only one who's not going to be here afterwards. Yeah. Does your model continue to retrain as people use it?
Yeah, so currently no. So right now the predictions are generalized, and it's trained from an initial set of data. But again, that's definitely an area that I could look at, and as new data is collected from each individual student, the model would adapt to his specific learning ability, and that's definitely one thing I'll look at.
Fantastic. Thank you very, very much. Don't jump away yet. Good. All right. I will hand over to Sophie May Press. Sophie is from Canberra and is in Year 12 and is going to talk to us about text summarizer, which is very exciting. Welcome, Sophie.
Thank you. Hello, my name is Sophie and I'm a Year 12 student from Canberra. I'm here to talk about the text summarizer I built as part of my assessment for Year 12. A text summarizer, as the name would suggest, is a program that is provided with an inputted text and produces a summary of the main point of that text. They exist mostly because people are lazy, but they're also an application of the field of computational linguistics and a way for computers to interpret language in a meaningful way. I chose to do this project because of my love of both programming and languages. I love languages because there's something I find inherently interesting about how humans communicate and how we interpret information with each other. It's also similar to the reason that I like programming, because it's about interpreting information and communicating ideas. So when I was choosing a topic to do within IT, this seemed like the natural conclusion. The development process lasted for the last 12 weeks. I spent about 8 hours a day. 8 hours a week. Sorry. Maybe an hour or two each day, or just 1 hour a day, depending on working on this project. So the text summarizer creates an abstractive summary of its input, which means it's different from just like picking out the key sentence, because it uses all the data the algorithm derives from the paragraph to create a new sentence that is of the meaning, like it carries the same sentiment. Okay, my basic process is in sort of 3 broad steps. The first step is to sort words by their type, for example, nouns, verbs, adjectives, adverbs, etc. The second step is to identify the most important words of each and any key phrases that are important, or any, I guess, groups of words that have to belong together. And then the third sentence is to reconstruct sentences and also ensure that they follow the English language's complex grammar rules. So the program starts by just going through all the words in the paragraph and sorting them by their type. It does this with a lot of files I created or stole, I guess, technically, from the Oxford English Dictionary and less reputable but still culturally valid sources, like Urban Dictionary. It searches through each of the files for a match and pairs them together. For proper nouns, which there isn't really a list of because that would be long, I add to the file each time the program is run. So it looks for words that are capitalized but aren't the first word of the sentence, like proper nouns are supposed to be, and adds it to a file of proper nouns. So while all the other types of files, verbs, nouns, and stuff are pre-done before I run the program, the proper nouns are like built on every time you summarize something. The verb file also has all the conjugations, so I don't have to worry too much about infinitive forms and all the other weird stuff that goes on with verbs. Yeah. The second step is to identify the most important words of each type. It starts by searching for the most frequently occurring words, and it also incorporates synonyms as the sort of same score, because if it didn't, it'd be kind of hard to find something that's the most important thing. With verbs, it takes not only into account the verb itself, its various conjugations, and also its general importance in the English language. So, for example, the auxiliary verbs to have and to be are treated as more important than, let's say, a less common used verb like to summarize. The third step is the most complex and kind of difficult to explain step, but it starts with the most major proper noun from the previous step, and then uses the Markov chain model along with the weighting from the previous step to produce the final output sentence. It also runs through a very large and complicated file of possible English sentence structures, which I had to write by hand, which was not fun. The language is terrible. Another part of reconstructing the sentences, which was also a massive headache, was putting all the clauses and articles in the right place and making sure everything just fits properly. Yeah. So a Markov chain model is a probability model that depends on transitions between states. It's a system that allows the predictive text feature on your phone to work, and it's also those things you see on the internet sometimes that like mash up Britney Spears and the Bible for hilarious results. Without going into too much of the specific mathematical details, the general idea is something like finding the probability that it will rain tomorrow given it rained today, or in my case, the probability that the word apple follows the word the. So as you can see there, that's some example code that just creates a dictionary of all pairs of words. So if in a paragraph you have the phrase the apple, and then later you have the bird, under the entry of the word the, it'll have apple and bird. I also developed a really quick and kind of simple and not particularly eye-catching interface for ease of use. So you just type in or paste in a paragraph, hit the submit button, and it generates the summary for you. Instead of doing a live demonstration, because it'll take a bit of time, and I'm also aware of the risks of doing a live demonstration, I'll just be showing a pre-run example. This paragraph is from the Wikipedia article on computational linguistics. As you can see, it's long and very detailed, but kind of a hassle to read, both if you're lazy and don't want to. Yeah. So when my program runs, it takes a while to load because there's a lot of mathy things going on, and then this is the result that came up. Yeah. As you can see, it's to the point, it's a lot shorter, and it's not a sentence that is just lifted straight from the text. It's just something it's taken all the data from and constructed itself. So, I wasn't done. My intention is to continue and improve on this project, and especially to reduce the runtime, because the point of a text summarizer is to save time. You're not really saving time if it takes 5 minutes to run. I also want to extend it to a more useful interface and be able to have multiple meanings from multiple paragraphs, and just generally you can use it on a full document instead of doing a paragraph at a time. I also want it to be a bit more pretty as well. Thank you all for listening. Is there any questions?
Thank you, Sophie. That was fantastic. As a computational linguist or a recovering computational linguist, that is exactly what I do with the straight commas and everything. That's all right. Amanda can help sort that out. Just palm that off to someone else. Sophie, there's a burning question. Malene has a burning question.
I really love the possibilities of this for assistive technology. Have you ever considered that?
So what are the possibilities of using this summarization work for assistive technologies?
Well, I think...
Into the mic. Steal the mic back.
Well, I think I have some friends with dyslexia who find that sometimes reading stuff that teachers make them read in class can be complicated. So I could definitely look at maybe applying that to making things of that nature being easy, not just for lazy people. But yeah, I would like to look at accessibility and assisting people who need it.
Fantastic. Excellent. Thank you very much, Sophie. Big round of applause. Oh, yeah. All right. Next up, we have Jasper Chandler. Take the microphone, Jasper. All right. Jasper is from Canberra. He is in year... Adelaide. This is what... I thought, yeah, I'm like...
It's only 11:45.
It was only... I know. Jasper's from Adelaide. Note to self. And is in year 11. Good. Okay, we were half right. That's a pass. Thank you, Jasper.
Hello, I come from Aberfoyle Park High School, and I've been learning Python for about 4 years. I've been working on my game Gnaw for 1 year. I began in year 8, but started by combining logic with mathematical functions and frame-by-frame scene drawing. This created moving images, and it led to me producing things like my first game, Boxscape, and many other trials and test outs. I then tried to make my own system for having points collide with a line at any angle. What I ended up with was a basic way to do calculus before I knew what calculus was. This gave me the idea for my current game, Gnaw. Then I learned about sprite nodes from Apple's Sprite Kit. This led to me making hybrids of frame-by-frame and object-oriented graphics. This is how I do things currently, as well as using shaders on the graphics. I quite often test out ideas in isolation using separate Python scripts. I play with the concepts that I find interesting before potentially combining them into larger projects later. In the top, you can see the fox that I made. The base of the code for the fox came from fox tail code. The code for that came from rope physics code that I wrote. And that's kind of the base of the code. It's based on just mathematics, trigonometry. This pattern continues throughout most of my projects, where big projects are based on smaller projects, and the small projects are based on mathematics or some idea I had. This is a game that I made my family for Christmas. And it includes this character, which I reused in my current game, Gnaw. The slopes collision code in here gave me the idea too. The first version of Gnaw used a generated array of points for the ground. It generated them from left to right. And my original plan was to use the slope collision code to detect the player's collisions with the ground. The problem with this is that my code was very buggy, and terrain editing would be very difficult to accomplish. So then I completely redesigned how my code works. I used the previous system to generate a bitmap image and then tested points on that image that are around the player. And if they're the color of the ground, then they're colliding. If they're the color of the sky, then not. This led to me dropping the slope intersection code altogether. And the grass started as special points on the ground, but once I moved to the bitmap image style of collisions, I made a custom array of points combined with seed integers to make the grass, bushes, and the trees. Each bush or tree has the seed, which then gets fed into a Monte Carlo random number system to generate the graphics. This gives the good effect that each branch on a tree is based on the previous branches all the way down to the base, which is dependent on the point, the seed. And the seed is dependent on the ground, and the ground is dependent on the level number. So each tree is guaranteed to be unique, and each level is guaranteed to give unique trees. I then started on shaders. I taught myself GLSL using demos from within the app I use, Pythonista, and on internet forums. My first attempt at shaders was the lighting in this I called alley test. The brightness of the pixels in the texture is proportional, or inversely proportional to the distance from the player. I use this system in my current game, Nor, to do the lighting. The demo on the left looks very simple, but it's actually very sophisticated. The white tiles are not sprite nodes, or even scene drawing. They're being drawn solely by the shader. The shader uses the player's position and pixel position to calculate whether any given pixel should be black or white. The demo is a stationary squid on a stationary white rectangle. The world is just shaded on top. I used a more complicated version of the same technique to do the mist, rain, and grass in Nor. At this point, I had a procedural, editable world, but it wasn't engaging beyond a passing interest. I observed from other games that engagement always comes from some challenge of skill. I then used a system I had come up with months earlier to create puzzles. The system was a way of notating logic gates using connected squares on a grid. I used the fact that NOR gates are universal gates and made every square a NOR gate. I then made top left sides inputs and bottom right sides outputs. This allowed me to construct logic from different formations of squares. This is what I made into a digital system and then into a game. Each puzzle has a specific goal, but the player can connect NOR gates in however they want to achieve the goal. For the right kind of person, these puzzles have proven to be challenging and highly rewarding. The movement of the player is done with a momentum attribute. Every frame, the player's momentum is added to their position and then divided by a constant. This gives the effect of inertia in the game and makes it easy to implement gravity as a constant negative addition to the vertical momentum. The arms and legs are animated using trigonometry and sine waves. The frequency of the sine wave of the arms movement is proportional to a constant frequency. However, the legs are much more complicated because the frequency of the legs animation is proportional to how fast the player is moving. This is why I made the sine wave demo on the right. It translates an x on one sine wave to a different x on another sine wave that has the same y location. This is using tangents and calculus that I won't get into. Please email me if you would like, and be sure to come talk to me with any questions. Thanks.
Thank you, Jasper. I think I may be just the kind of person that finds those sorts of challenges incredibly rewarding and addictive. Questions. While we do questions, can Declan come up and get ready? Questions. Yes. Christy.
My question is, you mentioned that you learnt a lot of the maths things around it before you actually learned that in school. Is that how you learned most of the mathematics around it, or did you find that there was some things where you learned it in school first and you were able to actually use that learning to apply it to the game? Just like from an education standpoint, like, is it a useful learning tool for maths?
I'd say definitely a lot of my knowledge from maths comes from my coding and random videos on YouTube. But definitely it's also the other way around, where what I'm learning in maths definitely helps me with the code. So it's kind of a two-way stream, but I'd say it's weighted towards me learning things with my code.
Okay, good. Thank you. Sorry, I'm just having a slight heart attack. Thank you, Jasper. Declan, I think, also just wants to keep my heart just going as I look up and say, the cable's gone bad. But it's all right. Because Declan Zammit is from Sydney. Declan is in Year 10, and he's here to talk about machine translation. Hence the yes, excellent. Thank you, Declan.
Hi everyone. So over the past 3 years of high school, if I've learnt one thing, it's that I have a very polarized set of interests. On one hand, one of my interests, Latin and classical linguistics, lies locked up in the distant past, and the other one of my interests, programming, holds the key to the very near future. It's hard to imagine any two subject areas with less overlap. Or at least that's what I thought until this year, when I was introduced to machine translation and the possibility of actually programming such a thing. So for those who aren't familiar with it, machine translation is very simply a program that can switch between two different languages. And my program, for example, switches between, well, actually that's misleading. It switches from English into Latin. Now, you might be asking, why would you ever want to switch from English into Latin? Surely you would want to do the reverse. My answer is, firstly, because English has a definite and indefinite article, which sounds sort of, well, it's got the word for the and a, which Latin doesn't have, which sounds very trivial, but I really didn't want to be randomly supplying definite or indefinite articles depending on the program's whim at the time, so I decided to go the other way around. The other reason for this is because any glaring problems with the program would be far easier to pick up for you as native English speakers, so I'll just leave it in Latin. Thank you very much. Actually, just as a show of hands, how many people are familiar with any vague degree of Latin here? Awesome, that means none of you will pick up the errors in my program. Okay, so I've just got a quick diagram here. There are four overarching points of machine translation. The first one is rule-based. That's what I did because it's the easiest. It's based on a set of rules. It grammatically interprets a language and switches it between switches it between the languages. The second is example-based, based on a corpora of bilingual texts. It looks at the text, it sees an example of where it sees something similar, and then it switches to the other one. The third one's statistical. It takes a large amount of information from bilingual corpora of texts, and it looks at the most common ones to see which translation it should opt with. And the fourth one's just neural networks, which it uses to create an idiomatic translation. Now, neural networks are Google Translate's most recent attempt at machine translation. It also uses, as far as I'm aware, example-based machine translation behind that, because not all of its languages are supported by neural machine translation, one of which is Latin. So, the reason I was inspired to do this program was overall because Google Translate exists in the first place. You see, because, or at least this is my thought process, because there aren't that many Latin texts which Google can use as examples for translation, its translations into and out of Latin aren't very good at all. So, for example, I know most of you won't understand this, but the phrase "anche la video," that's Google Translate's version of "I see the maid" or "I see the slave girl." But it's just very fundamentally incorrect. The slave girl is the object of the sentence here, so it should be "anche lam video." Now, any Year 7 Latin student should be able to tell you that. So the fact that Google Translate can't is slightly disturbing. So the goal of my program was simply to see the slave girl, which was to do better than Google Translate. Now, I don't want to put myself on a pedestal here. Google Translate is much better than my program. That's because it provides a far more general translation. It can cope for a wider variety of translations, and it will give you an approximate result. However, mine is more specific, and given a set of words which it understands, it can do a much more accurate translation. Now, right here, I've shown the process in my program. It looks at the words, it interprets them contextually, it finds out that it's indicative, it's present, it's active, and then finds the corresponding Latin verb. Okay, so why we might think now, okay, that's simple enough. We'll just create a dictionary. There's literally a dictionary in Python. We've got a dog on one side and canis on the other, which is the Latin equivalent. That seems simple enough, but it's not, because, of course, the program doesn't know how you're meant to decline the word for dog, or that the plural is dogs. Now, you could opt with a rule-based approach. Well, of course, the plural of any noun will end in S, but that's not the case either, because we've got cases like man and men. So, my program needs to know the singular English and the plural English. For Latin, it's slightly more complicated. For a general noun, you have the nominative case and the genitive case, which is just like possession. Now, that basically gives you the stem of the word, and it tells you what declension it has, which allows you to find all its different forms. To give you a general idea, most nouns in English will have 2 forms in different contexts, and a Latin noun would have 10. So it has to do slightly more complicated things. Now, I talked about nouns, but verbs are far, far worse. Right here at the top line, oh yes, I should say, this is effectively my dictionary. It's a text file with a bunch of words, and the first value separated by the comma will show you the type of word that it is, and then depending on the rest, let's just look at the verbs for now. It gives you the Latin words spector, spectare, spectari, spectatum, separated by full stops here. Those are the 4 principal parts of the verb. That's basically what you use to decline it, conjugate it, sorry. Then on the other side of the commas, we've got the English translations. Now, there are 5 English forms there. So why would we need 5 English forms? Because, same as before, we've got different ways that English verbs conjugate depending on how exactly they work. The first form is the infinitive, the second form is the preterite past, the third form is the past participle, the fourth is the third person singular, and the fifth is the present participle. Now, the fourth and fifth aren't strictly necessary, but due to a few irregularities, I found it was easier to include them in there. And I've done the same thing for other ones. I don't think they really need mentioning. So I created a Latin word class, which reads in this line of text and finds out its declension, conjugation, etc. Some verbs in Latin conjugate differently, so their deponents. Basically, based on the line of code and a set of very complicated rules, it finds out how it will decline or conjugate overall. So, how do you then get that into Latin? So I created a function within the class .latform. Very simply, it just has a bunch of space-separated words which will tell you how it's going to form. So genitive plural here would make canis into canium. If it was ablative plural, it would be canibus, etc. Now, how did I get those endings right there? I didn't explain that. So that's in another text file, which is latinparadigms.txt. It's got a whole bunch of endings as shown below in the line, which it just reads off and essentially suffixes to what it finds to be the noun or verb stem. Okay, so that's all easy, but now we're getting to the natural language processing stuff, and that's where it gets all weird. So if we look at the first example, which I've got below, go. I could say, go to the park. That would be what we call an imperative verb. I could also say, I want to go to the park. That would be an infinitive. And a finite verb, they go to the park. So obviously, based on context, my program will have to differentiate between each of those forms. Similarly, act, the acts of kindness, we could say that that's a noun, or we could say he acts out of kindness. That's a verb. So my program will have to distinguish between those. So then, first things first, it looks at all the possibilities. It appends them all into different sentences, which might be about 20 lines long. Then after that, it eliminates sentences which it deems through natural language processing not to make sense. So for example, it can't just have an infinitive lying there, and they go to the park. It has to be part of a prolative infinitive, which is where you have a verb like want, that's a modal verb, I want to go to the park. The want governs the infinitive. And similarly with those rules, like there are a bunch of them, and that's what my language did. Now there are also a few words which are just, they're not as simple as different forms of the same verb, they're entirely different words expressed with different ideas in Latin. So for example, the word to, because it can be a whole bunch of different things. We can say to go, I go to the temple, I gave flowers to the girl, or I went to see. Now all of those are expressed with the same word in English, but they're all different words in Latin, which isn't quite as easy. Also, the words like where and here, they are different when there's a directional. So I'm standing here. We can say that I'm just simply here and I'm not moving. Or we could say I'm going here, or I'm going there, which basically it has a directional emphasis on it, which means instead of hik, it's hook, or instead of eb, it's ilok or something. Then we've got words like who, which can be both the subject and the object of sentences based on word order, which I really don't want to go into here, but just know that there's a very annoying set of rules. Now, there are a few things which my program just simply can't do. That's because I figured it would be too annoying. Participial clauses. Basically, some clauses aren't governed by any, well, they're not clauses, are they? They're phrases. But they don't have any verb in them. They're just a comma. So, going to the park, I decided to do something. Right, that's a really bad sentence, but let's just cope with it. The verb, the participle, going, will change depending on the noun that is describing. We have to know that going describes I. So, the sentence has to iterate, the program has to iterate through the sentence and find what it's describing, which is basically really complicated depending on a whole bunch of different things, and I won't go into that either. The second thing is coordinative conjunctions. It sounds really simple, but the conjunction end was such a pain that I just decided not to do it at all. Because it can link to verbs, to nouns, to phrases, and I didn't want to do that. So yeah, that's it. I will go into a presentation very shortly because I know I don't have much time at all. Okay. I think the best thing to test right now would be just a very simple use of the different forms of to. So I, pardon me typing with one hand, I wanted to go to the, thank you, the temple to see the slave. Yep. Hopefully, please. Is that going to... Okay. I'm sorry. I wanted to go.
You need to rerun the program.
Oh, I'm sorry.
That's all right.
Okay. I wanted to go. Ire walui. In this case, it decides that the verb, that the word to is governing an infinitive, so it makes the word to go, ire, into the infinitive.
Yeah, it's not terminal, so Alt-Tab to go back, and then hit F5 again.
Yep.
I could have run it in command line. I didn't realize you needed to.
Okay, yeah, sorry. Or I wanted to go to the temple. Here it realizes that the to is also a preposition, so it makes it ad templum. Ire ad templum volui. Now, hopefully we can get... I swear this was working last time, but apparently not. Temple.
Declan, did you make changes to your code today?
Okay, yes, I've been working on it sort of last minute. I wanted to go, okay, there we go. So now it sees that to is governing a purpose clause. So it looks at the verb to see, it makes it subjunctive again, yada, yada, yada. That's Latin rubbish, which I don't want to bore you with. But anyway, I think that's all I have time for. Thank you very much.
Thank you, Declan. That was fantastic. We will be taking question in English rather than Latin, though, for now. While you're all thinking up a fantastic question for Declan, can we have Sam jumping up and getting your slides up on deck? Question for Declan. Yes. Up the back. Do you want to yell it out and then I'll repeat it?
As this is a Python conference, how does it go with translating Romans go home?
The question was, since this is a Python conference, how would your program go with translating the sentence, Romans go home? I'm not sure if these students are old enough to be able to have watched that particular skit, but I'll allow it.
Well, literally, I'm not sure how it would fare with the vocative. Yes, Monty Python, yes.
I think this is where you offer to do a demo afterwards in the hallway, and we'll test it out.
Yeah, if anyone wants to see how the program works, I'd be happy to do it then.
Fantastic. Thank you, Declan. Yes. While they're conferring, do we have a Casey Chung in the room? Casey? A phone was found and we believe it belongs to a Casey, so we're trying to figure out whether they're here. Looks like a no. All right. Sam. Sam Hogan is from Sydney. Here you go. That's yours. And Sam is in year 9 and is going to talk about a graphing calculator of sorts.
Yes.
Thank you, Sam. Welcome.
Good afternoon, everyone. I'm Sam, and I'm here to entertain you with a short 10-minute speech about a project I've been working on this year. I'm not really sure how I got selected, and I'm not even sure why I applied, but it may have something to do with the fact that I have double English on Friday afternoons. I come from Meibusch, a short 30 minutes from here by public transport, where I've been working on my project with a small amount of help from my amazing mother, Amanda Hogan, who spoke at PyCon last year. What I've made is a program that can turn almost any equation into a scalable vector graphic graph, which from here on I'm going to abbreviate to SVG. Now, an SVG graphing tool is all well and good, but why would you want one? Or more importantly, why would I? Well, at the time I had my idea, I was sitting in my Year 9 maths class, staring at a bunch of questions with equations that I needed to draw graphs for. And I hate drawing graphs. Art is not really my strong suit, and art that has to be accurate, no thanks. So this is pretty much the problem that my software solves, creating the graphs for me. There is an online software tool I had used before called Desmos.com, which is where I got my inspiration. Desmos is a wonderfully made JavaScript calculator made by a team led by Eli Lubarov, who was a math and physics double major from Yale University in the US. I decided it would be fun and lost my place, I'm an idiot. I decided it would be fun and maybe a little difficult to make a simple copy in Python. Like any project, there were clearly going to be some setbacks. Before I started working on the code, I had the idea to write this in Python Turtle because it was something I knew and it was pretty easy for me to use. But after some careful consideration, I figured it wasn't the best idea because it would be slow to render the graphs and it would take too much processing power for complex lines. And so it was back to the drawing board. But this time, I had no graphing medium. This was pretty easily fixed with some simple browsing and searching, which is how I found out about SVGs. I started coding in Sublime Text and running in idle. However, this was not optimized for the web, and I knew that I'd want to be able to show it off to lovely people like you with live demos, so that really wasn't going to work. It was then that Trinket.io was mentioned to me by my code guru mother, and I quickly decided to use that. As I continued working, though, it became apparent the library I was using, SVGWrite, was not supported in Trinket.io. This meant that I had to look into the SVG file in Sublime Text and figure out what I could reverse engineer. Most basically, what's inside an SVG file is text, and I had experience manipulating text files from the NCSS challenge that I do every year. So to get this to work, I made a graph with my original code and analyzed how the lines were drawn by reading the SVG in a text editor. I then had to make my program loop through the equation and input the x and y values of the points into a really long string and then put that back into the file. Okay, now I've done some explaining, let's take it for a spin. I will do some basic showing off of my program and then take some requests, but please, nothing that could cause Python to crash. Okay, I'm done. That's all I'm done. Okay, so okay. So I have implemented two different ways to input the equation, and reverse Polish notation and usual. So I'm going to start with normal. A problem I had when trying to input my graphs was I was tired at the time and forgot that you had to do double asterisk for powers, and so I had done something like this, and it does give a result. However, it's really not the result you'd expect. And so after looking at that a bit and possibly sleeping, I quickly figured out that I had to do this. I have implemented a scale into my code so that some equations will look small and not be easy to see, and the scale can fix that. Just to simply show off the scale, I'll do exactly that one again, but with a different scale. If I double the scale, the line will look more jerky, but it will be more pronounced. Okay. Now, to do some simple ones in reverse Polish notation, which I have a slight grasp on. The good thing about reverse Polish notation is that I've implemented it in a way that I don't have to write double asterisk. And so it even works when I'm tired. And we get the same graph, because I'm boring. I just need to quickly copy something from my notes. Yeah. Okay. The scale needs to be bigger on this one, so you can actually notice the difference. This is taken from actual testing for the reverse Polish notation module that I've implemented from different code that I've done. And now for the final one, please do not break. It does work, but I've had to make it work. Oh, I need to change the scale. Sorry, I forgot. I'm smart. So it does work, but you'll see a strange dip in the middle because what I've done to avoid the division by zero error is mention that if it's ever dividing by x and x is 0, make the value 0. It means I don't have quite a very smooth curve as you'd expect. And so I'm going to take one request from the audience for an equation, if that's okay. X cubed, okay. Oh, it's cubed, sorry. Smart. I'm gonna go with this. Hopefully the scale's big enough. It is. It doesn't grow too badly. Okay. Now, back to my slides. Give me a second. 1 second. Wait. I can do this. Seriously. Oh, I see. Okay. So, oh, no, I'm smart. It's working. Amazing. Okay. Okay. Okay, so now I know this isn't the perfect project. There are still a couple of things that I'd like to do. So now I'm going to tell you where I'm going with this and how I'd like to improve this project. In concept, graphs shouldn't just be done with equations. You should be able to plot points on the graph and use those to make a line to show data with. Another addition I could add to make it more fun would be to be able to change the color of the line. Change the color of the line. A suggestion I've had would be to try and recreate Python total module, badly of course. This sounds really fun and difficult and would make use of my newfound skills. Okay, so if there's one lesson to take from this, it's that I just found something and copied it. And I think that's a great lesson for life. So anyone looking for inspiration, copy something useful or even something completely unuseful. Just copy it and have a play around and you'll learn some useful skills along the way. Okay, the speech is actually finished now, but I have time for a question or two, so shoot away.
Excellent, excellent work, Sam. All right, so we need a question for Sam and Aden. Come and get your slides up. A question for Sam. Excellent.
Hello. I was just wondering, does it have a limit on the amount of terms that you can have in the equation?
The question is there a limit on the number of terms you can have in the equation?
Yes.
Yes, I believe you can only... I've only tested it with X. I believe you can... actually, no. Yeah, my code makes it so that you can only run it with X as a pronumeral.
I mean, like,
for the...
you have x squared plus 2x plus 7x, well...
Yeah, you could do that.
Sorry, just for the recording. So could you have x squared plus 2x plus 7...
Plus x cubed.
Plus x cubed plus...
Like a limit on the amount of terms.
There is not. You could do that as many times as you want as long as you don't exceed the number limit for Python, which is possibility.
Seems pretty safe, though. Thank you very much, Sam. All right. Excellent. Next up, second last, we have Aden Pham from Canberra. Aden is in year 12, and he's going to talk about emojis.
Emoji-fire.
So excited. All right, thank you, Aden.
Hello, everyone. So today I'm going to present about Emoji-fire, and it is a machine learning implementation which will give a sentence and emoji. So you guys could check out the project on GitHub, and then here's my GitHub. And if you want to contribute to the project, just do a pull request, and I'll review it. All right, so let's get started. Okay, so that's right. My algorithm could give a sentence an emoji based on the sentiment or the context of a sentence. So for those of you who read about the dawn of AI would take over the world soon, like Elon Musk or Mark Zuckerberg, don't worry about that. Like, it just took an IQ test yesterday, and then statistically, it has an IQ of less than 3. So it's not even as smart as Cortana or Siri. And yeah, Cortana Siri is dumb. So my name is Aden, and here's my Twitter and my GitHub handler, in case if anyone wants to follow me and hit me up later on. And I'm in senior year at Garland College, and I'm a React dev for about a year now, but just for freelancing. And I'm really into web development, machine learning, and all about this design stuff. So Emoji-fire is available on the 2 networks. The first one is recurrent neural networks and long short-term memory networks, which is another advanced model of recurrent neural networks. But I will not go into details of how it works, and yeah, because it took me 2 years learning it, so I can't just explain all the stuff in 10 minutes talk. Okay, so I've used... That's right, it's obvious. Okay, so I've used Keras and Flask for building Emoji-fire, so just a bit of survey. Who here has used Keras before? Probably 1% of you. How about Python? Okay, that's right, I'm in the right audience. Oh, calm down. Okay, so yeah, Keras is simple. It's easy to use. You learn once you write everywhere, especially you learn in Python and you can write in JavaScript or C, C++. Not C is an outdated language, but of C++ as well. And with Flask, it is a backend library, it's a library for developing backend in Python, and yeah, it is simple to use as well. Like I make the server for user to fetching data from for emoji file in less than 10 lines of code. So here's a code of emoji file. I'm just gonna quickly go through the code to prove you guys how simple it is to use Keras with machine learning stuff. So first of all, I define the model and just a bunch of junk arguments that you don't need to care about. And then you get the sentence, and then you input the sentence in the model, and then you just load the embedding layer. So what embedding layer is converts, how do I say, converts words into vectors of numbers per se, mainly because computers can't really read words, so we have to convert them into binaries, which is numbers. And then you define the first layer of the model with drop of 0.5, so you would have different types of layer depending on what types of networks you're using. And drop we make the model to have real life experience, or like make the model to be practical. And second layer we draw 0.5 and dense layer, and just get the output through a softmax function, which we will be learning through calc in your maths class, or just, yeah. And then you create new model instance and return it. And then with Flask, I learned Flask through this. I learned Flask from this book, Flask Web Development. And then our class spent 3 months reading his book. And then we had to build a complete app. And then we had to build a blog out of it. And yeah, and his the author of this book is Major Greenberg, and yeah, he's a lovely American guy here. Even though I haven't met him before in real life, but you know, since he's American, so we just all assume that he's super nice and friendly. Isn't just the stereotype. Okay, so let's go to the demo. Could anyone, where is it? Could anyone give me a sentence? Give me something? PyCon is what? Oh, right, PyCon rocks. I don't know if it knows the word PyCons or not, because it's not in the dictionary. Okay. Oh, Python rocks. All right, yep. Here we are. Missing the all in here. And then you just need the number of emojis you want at the end of the sentence, and then just click on get emojis. It will take quite a while because my server is serverless. So when you're making the request to the server, it will wake the server up, and then it will initialize. Oh, here you are. I don't know why there's so shit up here, but all right. So okay. Chew. All right. So lesson making emoji fire. So best way to learn is to teach. So when you teach someone, you actually learn twice because you gotta like read the material you want to teach them, and you teach them. As I record, when I first learned machine learning, I had to like get as many friends as possible to learn machine learning with me because I could teach them something. Okay, and jump in head first. What do I mean by jump head first? Also, pick a project you want to do, and then just stick with it for the rest of your programming career. I'm not exaggerating. And whenever you learn new things, just try apply those new things into that project. As in Emoji Fire, this is a project I did 2 years ago, maybe 1.5 years when I was learning Python in Grok Learning. So essentially, you input in a word, and then you will give that word either a sad face, a smiley face, or just not sad, not smiley, neutral face. Depending on the sentiment score of the word, if the word has positive sentiment score, then it will output a smiley face. If it has a 0 score, would be a neutral face, and then the rest is the sad face. Okay, so pairing. I'm a huge just okay. I'm a huge fan of pair programming. Like it's just so great to have everybody. It's just so great to have everybody sitting next to you to be able to ask questions and then learn how they write the syntax, learn how they write their code, and then copy code from them. Yeah, and Stack Overflow is the best programming community. Just yes, sure. And just try answering questions, reading questions every day if you can. And yeah, to be honest, if it were not for Stack Overflow, I wouldn't even passing my IT classes. Okay, thank you. That's all. Do you have any questions?
Thank you. That's a risky thing to say, that you wouldn't be passing your class knowing your teacher's in the room.
Guys, that's
living dangerously. All right, could we get the last group up on deck? As we have a question. Do we have an emojifier question?
Everyone loves
for
emoji,
Aden?
right?
Yes. Up the back. Shout it out. Yep. I'll repeat it.
So where did you get the data to train?
Oh, okay.
Hang on. I've got to repeat it first for the recording. Where did you get the data to train the program? To train the neural network?
Okay, so here's some statistic about my networks. So currently, the accuracy for the training data is 90%, and for real life data is 80%, 70 to 80%. So it is underfitting now. But with that training data, it has 2,000 sentences, and I made up all of them.
So they're your emoji responses to the training data.
To me only.
You manually made.
To me only. So
wow. You're an emoji expert. That's fantastic. Excellent. Dedicated student. Thank you very much, Aden. All right. Our last presentation is 3 students presenting one thing. So there's going to be a bit of mic passing back and forth. We have, Aden Pulford, yes? William Meibusch? Sorry. We should have done this earlier, but I was too distracted by the things you're going to show later. And Victor Horvat. And they're from Canberra, and they are in year 12. Thank you very much.
Good evening, everyone. My name is Aden Pulford. This is William Meibusch and Victor Horvat, as you just heard. And so for the last term or so, we've been working on a project called Pavlov's Dog, named after Pavlov's dog. And so, the whole purpose of this project was to help ourselves understand the concept of neural networks. Now, neural networks are not necessarily the most intuitive idea. And so we learned this through the metaphor of training a dog. A dog, if you want it to not be on the rug, you take it outside when it goes on the rug, and eventually it learns that if it wants to stay inside, then it doesn't go on the rug. And so we took a similar philosophy in regards to training our neural network. And so the other purpose of this project is to demonstrate classical conditioning in reference to Pavlov, that guy up there. So for our project, we used a lot of libraries. For the simulation and the GUI, we used Tkinter, PyMonk, Pygame, the AST library, which I'll never remember what that stands for, and math. And for the dog creation kit, which is another part of our software group we used Pill and OS, and for the neural network, we were using Random and NumPy.
Neural networks simulate the inputs and outputs that are modeled from human learning processes. The inputs from the human brain, they range anything from the extensive amount of nerves to the visual and the audio sensory. And they express their outputs through actions, thoughts, and emotions. Pavlov's dog has a left and right motor as our outputs. There you go, the next slide. These outputs are determined by the readings from the 3 ultrasonic sensors, the 2 light-dependent resistors, and a bias unit. The inputs are multiplied through a matrix to produce the output, and which is ultimately sent to the motor as data. In between each of the nodes, the neural networks has weights to determine the thinking process. When the output is reached, it is compared to the data array of the inputs and the outputs, and the network initiates the backpropagation algorithm to basically train and learn from its previous mistakes. The backpropagation works backwards through the weights, corrugating them to align the actual output with the desired output from our training data.
So there are several components of our project, and the best way to outline this is to go through a use case. So the whole purpose of the simulation component of the project is to train the network for the physical robot. So the average user will start off in the dog creation kit, where you put the components of the dog together. Now this could be chassis, wheels on the left and right side, bump sensors, LDRs, that sort of thing. And so after you've done that, you flag them for the certain types of collision they are. So for instance, an LDR will collide with a light object. And then this dog that has been created is dropped into the simulation environment, where you can see a screenshot of it up there. The simulation environment is constructed by the user with objects that they create themselves. And these objects are able to interact with the parts of the dog. And before the simulation is started, the user also creates a rule set. So hands up, who here has played the original Dragon Age? Explain. One person. That is an excellent success rate. All right. So for everyone else in the room, you can create a rule set for what happens under certain circumstances for your party members. So for instance, when you enter into a battle, you can have a party member drink a certain potion, or that sort of thing. And so these are formatted, in this case, as sensor is a certain value. So for instance, an LDR is activated, then you either punish or reward the dog. And so that is fed back into the network when it's actually running it. So you run the environment and you let the network go and train. And when you're satisfied with the state of the network, you throw it into the robot.
So here we've got the motor IC. This is basically just some of the circuitry that the motors relied on in order to work, or when they did work. So we've got the Arduino, and that's giving the signals to the H-bridges, and those are the huge components to the left and second from the right. Yeah, and so the motors are running through that, and that's because the Arduino can't output enough power for a regular motor to run. So we use the H-bridges to subsidize for that. So this was our robot about 72-ish hours ago. Okay, so we've got the Raspberry Pi, which is running the neural network at the very back. It might be a bit hard to see at this angle now that I actually see it. We've got the Arduino Uno, which is in the middle, and that's taking in the sensor inputs, and it's also giving out the component outputs, so that'd be our motors. And then we've got the IC, which is taking the Arduino outputs and then running it to the motors. So, as is customary when making anything, things go wrong. And there's not really a limit to what went wrong here. So now we'll start the list. So as far as hardware problems go, as it turns out, laser cutters are really hard to use if you accidentally use inches instead of millimeters as your unit of measurement. As someone that's grown up using the metric system, it was a little bit of a setback. Also, if you spill water all over your teammate's laptop about 3 hours ago, that also doesn't tend to do a lot of good. Okay. Another thing is the batteries die. We were using 9-volt batteries for power, and so we measured them at about 8.61 volts-ish, and then about 40 minutes later, they were down about a volt. This was done, though, while they weren't actually in a circuit, so they just drained all that power out of nowhere. It might be because the batteries are 3 years old and because we're too cheap to buy new ones, but yeah, so that happened. And the other things would be that 3D printing takes forever. Printing, about half of it took around 5 weeks of the school 3D printers running 24/7, and then we also used our mechatronics teacher's 3D printer at home to print the rest of the tracks. It printed a lot of linguine, which, although is not great for treads, it tastes amazing. And as far as where the treads are, they demanded a ridiculous power draw from the motors. So if we put the treads on, then we can't actually run the motors. So we took them off. So we took them off, but as it turns out, the treads are a really important support feature of the wheels. So if we then put the dog as it is on the ground, the wheels will just snap off. So if anyone's hesitating about wondering whether or not they should make whatever they've made from software into a hardware version, I urge that you continue to hesitate.
And hardware issues weren't the end of our struggles. So this entire thing was a learning process for us, and there are a number of lessons to take away. The first thing is, don't have a plan as you go approach to creating your backend, because at first it may be able to go ahead quite smoothly, but if you don't have a complete, concrete understanding of the APIs you're using, it can become a mess very quickly, and you can end up having to redo it twice. And as well as this, even though we have had roughly a term of continuous work on this project, we've had to learn a lot of the APIs that we're using from scratch. And so an example of this was PyMonk, which we use to handle the physics of the simulation software. Now, the interesting thing about this is PyMonk is designed for a 2D vertical physics simulation rather than a horizontal one. And so we had to account for that because it does not have native support for wheels or similar things. We had to come up with our own solutions for this. And they aren't 100% accurate, but they are far better than anything we could have created without using a physics engine. As well as this, we at one point had our entire project in Pygame in terms of the GUI, and we had to move from that into a combination of Pygame and tkinter, which also took time as we had to learn tkinter for that. And so I think it's quite clear that there are a lot of areas for us to push further forward with this project. It's not so much of a question of what are you going to do, as what aren't you going to do.
Supposed to do.
Yeah, exactly. And so we're going to push it to completion. We're not going to give up on this project. And we're going to polish it until we believe it's at a final product state. And we're going to continue to extend its use cases into more and more dynamic states. Thank you.
Thank you very much. I don't want to get too close to the robot just in case it falls over. More? Questions? Do we have questions for Aden, William, and Victor?
I know our colleagues from school were told not to ask questions, but they're allowed to.
That's all right. We've got a question from a colleague from a different school, so that's all right. Jasper, ask away and I will repeat it.
Why is everyone so interested in neural networks and natural language processing?
Why is everyone so interested in neural networks and natural language processing? I'm actually going to take that question afterwards and answer it. But is there a question about the pipe? Yes, all right, at the back.
So it was
What were we training the robot to do?
basically what it's told to do. If you have a look, it's a general case. If you have a look at the screenshot of the GUI up there, it's very hard to see at that resolution. But there in the window that's floating in the middle of the green, there's 3 tabs at the top: Rules, Objects, and Simulator Settings. Under the Rules section, the user creates their own rules, and so that could be anything from if you're in light. So if the LDR input is active, then punish the dog, so that it learns to not be in the light, which, now let's say out loud.
So, thank you so much. Round of applause. Gentle round of applause so that the reverberations don't cause the batteries to explode or something. So, Amanda and I are going to do a quick roundup just to talk about this and the showcase a little bit more. But if we could have all of the student presenters first to come on up. I'm not going to mug you. Instead, we have some fantastic stickers for you all to take home and adorn your laptops or whichever rooms. School siblings. Yeah, if that's what you want to do with your valuable stickers, then absolutely. We've actually, because these students were so fantastic and stayed to time, we've actually got time for another quick couple of questions as well. If you wanted to throw back to any of the talks. I was particularly harsh at pulling only one question before per talk. Katrina.
Can we have another demo of the Emoji-fier?
I think we can have another demo of the Emoji-fier. Yes, but hang on first. Yep.
All but Joseph. Sorry, Joseph.
All right, let's get a demo of the Emoji-fier. Hang on, there we go.
Are you doubting it's not working? Or I just have a bunch of if-else statements?
Oh, you were too fast, so I couldn't get a photo of it before.
How do I?
Yeah, I know. How do I Windows people?
It's an important question. How do I Windows?
So, what one do you want to try now?
What about something about the horrible weather right now?
It is raining cats and dogs.
Yes, that sounds like a good one.
I just don't care about the junk above.
Hey!
Yep.
That is fantastic.
Thank you.
Any other questions? Kiki first. Yeah. Hang on. We'll run the mic to you.
Thank you all so much. Firstly, that was fantastic. And I think for me that's going to be a highlight of the conference. So, this is a general question to all of you, and some of you may not know the answer to this yet, but I'm wondering, how has the experience that you have had in creating these projects influenced what you are thinking about doing in future, perhaps for a career?
No pressure or anything. Just think about the hopes and dreams of all of your teachers as you answer this, that it may be in the room.
So in my case, I'd already made up my mind where I wanted to go for university and where I wanted to go career-wise. However, I think the number one lesson I've learned from this is that when you throw yourself in the deep end, you learn to swim a lot quicker. So with programming, if you paddle around with the easier questions for ages, you don't develop the understanding you would if you were to undertake a long-term project. And that is something you can apply in almost any situation to basically stretch yourself as far as you can, because it makes the smaller things a lot quicker to pick up. Does anyone else have something?
Was that you reaching,
Any other
Izzy? No?
No?
Did you all
No.
learn anything else?
We're all
Repulsed
terrified.
by the microphone. There was one more question down the front here.
Specific, so sorry, I didn't have a good general question. It was the young lady who did the summarising. I was just blown away with that, and I can imagine students in senior years wanting to drop their notes in from the class and have this program spit out a short summary. And did you think about that when you were creating it?
Yes, I didn't really like reading all the really long notes that I got in physics. Sorry.
Yeah, yeah. Great. Thank you all so much. Massive round of applause to everyone. Cool. Go and you may sit down. Oh wait, hang on. Collect your appropriate stickers. You can take, if you'd like to walk your robot around, or the remains of your robot around, but don't run away just yet. Here we go. For the rest of you teachers and educators in the room, what Amanda and I just wanted to really quickly run through was why we decided to run this student showcase. So last year we had we were in the audience watching some of these fantastic talks, including at PyCon, including some talks from students, and we really wanted to have a showcase to demonstrate the range of projects and the range of things that students are working on across Australia.
And we think that, we think that Python is a fantastic learning language. It's the language I relearned after a long time away from programming. So it's really accessible for the shallow end, but then it's so extensible for these amazing projects.
It was really heartening to hear a lot of students talking about taking on some really challenging, hard problems, some of which were problematic and exploded in miraculous, fun ways. But that they had the confidence to do this, having built on starting to learn to program in earlier years, building on small resources that have been mentioned a million times today, but starting small, but aiming at this. I mean, the projects were from year 7 to year 12, so I can't really say waiting until the senior years to do amazing things. We're really blown away. We hope that all of you are, and all of the viewing audience are. And if you as a teacher, as an educator, want to find out about how you can start to develop these sorts of projects in your classroom, get in contact with us, and we can get you.
The ACA will help you to do that, and we can leverage the fantastic talent in the room of the teachers that mentored these students, but we have resources that can help with that as well.
So you can get in contact with us at the Australian Computing Academy. Look us up. The other question.
Go Windows.
That was well timed.
That was really well timed.
Do we need to go back to the poop emoji?
She's
so
anti-Microsoft.
No, just we weren't specific. Despite the fact that I am actually a computational linguist, I did not select for computational linguistics projects.
No, it was a fluke.
Nor did we select for neural networks, but we were just blown away by the superbly amazing projects that are cutting edge things that are being developed by students. Much like all of PyCon, this review process was anonymous, So congratulations to all of you. You are all fantastic. And we're really looking forward to next year making some really, really hard decisions.
When we get a flood of student applications. And I want the teachers to take away that you don't have to baby feed students. You can support them in the deep end, that they come up with some amazing things.
And learn a lot of things, whether the project works or doesn't.
And yes, you have to design your assessment guide so that if utter failure is,
that's a bit
the
harsh.
outcome, it's a bit harsh. Utter project failure, then you can reward the effort and the learning, because that's the thing that's important.
Yes. So can we get one final massive round of applause for the effort and the learning and the super dedicated teachers. That's it. That's it. So we had a closing slide. The closing slide said thank you. Instead, I will say thank you rather than risk more updates. Thank you all so much for joining us here in the Python education mini track at PyCon AU 2018. Whether you were here for one talk or the whole day stuck in a room with us. Thank you, Nick. Yes. You're hiding up the back, but thank you for the amazing work you've done. Thank you for the amazing support from PyCon.
Yes.
We are looking forward to
relaxing
and
enjoying the rest of the conference.
Sitting alongside you over the next 2 days, listening to some more amazing talks. All of the speakers will, most of the speakers will be here on the weekend as well. The other microphone has disappeared. It's on the stage there. So tap us on the shoulder, tap the speakers on the shoulder. If you have more questions that you didn't get to ask, go up and ask them. And remember the Pac-Man rule. Remember the Pac-Man rule. That is still in place tomorrow and the next day, and possibly even for the rest of your lives. Yes, thank you.
And I'm just going to sneak in and say one last thing. Thank you to Nikki and Amanda for all the amazing work they've done putting today together.
Our absolute pleasure. Thank you. I believe there will be loitering outside, and the Slack channel has a place where you can go for dinners and stuff with people to talk about awesome things.
Yay.